what is the minimum percentage of gasoline stations? So they're really emphasizing that at least feature of Chevy Chevs here. Had prices between $294 and $318. $294 to $318. So what's the percentage there?
75%?
75%. So how many standard deviations did you add and subtract there, Mike?
2.
2? Okay. You guys agree? So you want to know how far you have to go out to get these numbers, right? 294 to 318. So you just take the mean, subtract 0.06. You there yet? Not quite? Subtract 0.06 again. So you've done it twice, right? You did 294? Yeah? Okay. So how many standard deviations have you subtracted? 2. So you should add 2 to get to 318. Is that correct? Remember, not adding the number 2, you're adding 2 standard deviations. Okay? So take 306, add 0.06. You'd get 312. Not there yet. Add another 0.06. To 312, you've got 318. So you're going within 2 standard deviations, and how much data there? 75%. So then you go back and apply the rule. You guys with? Okay? Awesome. Awesome. Okay, let's look at one more. You guys try it, and then we'll do it together. Try the number 40 there. If you have questions, raise your hand. I'll come help you. So if there were fewer of us, I would request this room more often, but I hate to cram you guys in here like sardines. Whenever we can get a video, we'll come back here. Good one, good one. Yeah, so part B, you guys, right? We don't have that. We don't have that established yet, right? 1.5 standard deviations. We've got 2, 2.5, 3, and 4. So for any other distances away, you've got to take that value of k, which is 1.5, stick it in that tiny little formula, 1 minus 1 over k squared, and that'll give you your percent. Make sense? So how'd we do on A? 75%? Okay, so here our variable is the commute time for a resident of Boston, Massachusetts. Okay, anybody ever been to Boston? Oh, I highly recommend it. Isn't it gorgeous? It's a great city. So our variable is a commute time for a person in Boston. Okay, it has a mean, these commute times of 27.3 minutes and a standard deviation of 8.1 minutes. Okay, so notice here that it doesn't say anything about the distribution. Therefore, we automatically use Chevy Chevs. Okay? What's the minimum percentage of commuters in Boston that have a commute time within 2 standard deviations of the mean? Any math we have to do? You're just going to apply the rule, right? How much data is within 2 standard deviations? 2 standard deviations. 75? 75%, yeah. What minimum percentage of commuters in Boston have a commute time within 1.5 standard deviations of the mean? Ah. So for part B, we're going to have to use our little formula that tells us the percentage within a certain number of standard deviations. If the number of standard deviations is 1.5, plug that in, So you have 1 minus 1 over 1.5 squared. And you can just type that right into your calculator. 1 minus 1 divided by 1.5 squared. No parens or anything, and you'll be golden. Anybody get that? 56-ish? Cool, great. 56%? So at least 56% of Boston commuters have commute times within 1.5 standard deviations of the mean. What are those commute times? So you're going to take the mean and subtract 1.5 standard deviations. You're going to take the mean and add 1.5 standard deviations. So we've got 27.3 minus 1.5 times 8.1, okay? The mean minus 1.5 standard deviations, and then the mean plus 1.5 standard deviations. So about 56% within what times?
15.15.
Say 15.2
Yeah. And 39.5.
and 39.5 minutes. So about 56, at least, right? At least 56% have commute times between 15.2 and 39.5 minutes. You guys with? Questions? You doing all right? Okay. All right, so how about C? What is the minimum percentage of commuters who have commute times between 3 minutes and 51.6 minutes? That sounded like a lot.
I think it's
3 to 51.6?
I think it's 3 dB. I think it's 3 one way,
Yeah?
and let me see.
We don't have that symmetry with Chebyshev's theorem like we do with the empirical rule. So they should be pretty straight about the intervals, pretty even intervals. Okay, so take your mean. How many times do you have to subtract 8.1 to get to 3? 3 times? So you take the mean, subtract that. You there yet? No. Subtract that again. Are you there yet? No? Subtract it one more time. Are you there? Okay, so you subtracted 3 standard deviations, correct? Okay. Then you take your mean, 27.3, and add 8.1. Are you there yet? 51.6? No? Add it again. You there yet? No. Add it one more time. You there?
Yeah.
Okay, good. So we add and subtract 3 standard deviations to get from 3 minutes to 51.6. How much of the data is within 3 standard deviations? 89%. So 89% of commuters have commute times between 3 and 51.6, minutes. Does this make sense? You guys on board here? Is this all right? Is it? So remember, with the empirical rule, you have this symmetry. You don't have the symmetry, doesn't matter. Just use Chebyshev's. Okay? Again, it's a means of tracking your data, okay, within the distribution. And we will also talk about, later on in the chapter, a calculation that will allow us to find the exact placement of a data value within the distribution in terms of standard deviations. And those are Z-scores. So a couple more sections and we'll be there. But for today, 3.2. Woohoo, there it is. Thank you. Have a great day. Scott, what's up?